Hi everyone, my name is Eric. I'm on the Nebula team. I'm here to present to you our submission for the Sustainable Blockchain Hackathon, and we're calling it the Indoor Farm Environmental Impact Data Tracker and Explorer. So let's get started. A little bit about us. Nebullam is an indoor vertical farm. We're located in the heart of the Midwest, and we basically built our own fulfillment stack. We're really focused on reducing food miles, better serving our local communities year round, and we use a direct to consumer delivery model. That allows us to do things like, for example, we use reusable bags and less packaging in general to try to reduce our footprint. Overall, we're really focused on data, sustainability, etc. And that kind of led us to decide to take this hackathon as an approach to explore an approach to using blockchain technology for environmental impact tracking. So we think it's kind of novel, but also something that's accessible enough for other indoor farms to really take advantage of. And it's kind of inspired by our own efforts to reduce our carbon footprint. So farming, if you don't already know, it's a pretty energy intensive process. There's a lot of coordination and regulation of inputs because ultimately you're trying to maximize the response yield that you get from the farming procedure. And indoor farming in general, it has been shown that it can reduce the carbon footprint of crop production, but that hasn't been quantified to the extent that you'd call scientifically sound. We don't have exact numbers of what that is. We're hoping to help go in that direction if we can continue the process of collecting and analyzing data. And specifically for us, as our farm expands, we've been investing capital into how we can track our own energy usage. But not only that, also share that information with other indoor farms. And so ultimately, it's basically a way that we're trying to promote and support open data standards in the indoor farming industry. And to that end, we've developed this application and a data schema, which we'll talk about, that serves really as a proof of concept on how blockchain technology can be utilized to create what's called an immutable record of energy usage and hopefully a study of the environmental impact of the indoor farming industry at scale. So I mentioned that schema, and I think that's a really important point to cover. We developed this open data standard, and we've tried to basically strike the balance of it being both comprehensive enough to capture the information that will allow us to track environmental impact, but also simple enough that this can be used by a wide array of indoor farms as a standard that we can agree on. And so basically the structure looks like what you see on the right here. The columns are the harvest date, the location, the response variable really that you're interested in maximizing, which is the yield, and then some metrics of the environmental impact or footprint like water usage, fertilizer usage, electricity usage. And then some factors related to both the product and the farm. So in this case, the product type, which for Nebullam would be things like butterhead lettuce, rainbow chard, strawberries, etc. And the farm, if there's multiple farms, multiple locations to track, where that observation originated. So this format really kind of hosts the minimum required information to begin tracking the input for indoor farms and the influence of those inputs on yield. And what's cool is a farm really can append their own information to this file in order for us to create a shared record of usage over time, which you can imagine can be used for all sorts of environmental impact tracking. What's really nice about it is we want this to be an open standard. So agreement on new columns, for example, can be conferred by participating farms. If we need to further extend this schema to support other use cases, that can certainly be a possibility. And our application really is another example of the way we're really leading by example. And so I mentioned we're calling it the Indoor Farm Environmental Impact Open Data Tracker and Exploration app. And what it was really built to do was to show how IPFS, or the Interplanetary File System, can be used to host an immutable, and that's important, record of the vertical farm energy usage. It's independently verifiable, it's perpetually available, And that's really something that you don't see too often when it comes to data tracking of farms. So it works really by having the user connect to a cloud service through either their IPFS node or Pinata. And then all you have to do is upload your farm data in the format that we showed you before. You get a CID returned that you can then use to visualize your results through the application. It's really, really easy. And it's so easy that we might as well take a little detour here to show a quick demo of it and look at the application itself. So I'm going to go ahead and back out of this, and I'm going to execute the application. It'll come up here. You'll see I have my IPFS daemon running in my terminal right here, and it immediately sees that and connects to it, which is pretty cool. Nothing more to it. If that daemon was not running, when you run the application, it will immediately tell you that, but it's as simple as start that daemon, load the application, and you're connected. So I'm connected, and what I'm going to do is I'm going to go ahead and upload my farm data. So this is a CSV file in the structure that we showed you, and I'm going to click it and then click upload farm data. And you'll see extremely quickly I get a data CID, and you get a QR code, a link, all these things. You can click the link, you can scan the QR code, or you can take the CID, go to the Visualize Farm Data tab where you're able to paste a CID. And I'm just going to click Analyze Farm Data. You'll see how quick this is. It processes that data and gives us all kinds of interesting views on how we can track the various metrics over time, both yield and also metrics about the footprint. So here's a macro view of the yield over time, which you can see with the little smoother applied. Remember that there's those categorical variables such as product type. So you can analyze the yield over time by product type. You immediately see certain products, were introduced more recently. So there's different time scales for the products. And likewise by farm, same deal. So if you have multiple farms, you can see all the farms at once and basically do a direct comparison between them. Now that's the yield over time, but remember we're also tracking the footprint. So for example, here we have yield versus water usage. This is the macro view for all the farms, all the product types. But once again, we've broken it down by product type for you. So you can see how does that vary across product types? Are they the same? Are they a little different? And likewise across the different farms that you have. Similar thing with fertilizer. So a macro view initially for yield versus fertilizer usage, and then a product level view. So you can see the differences between your different products, and a farm level view right here. And lastly, that electricity column, same deal, a macro view. You can see this plot is a little bit different in terms of the structure of it, but same idea. There's a macro view, a product level view, and a farm level view. And through these different views, what we're essentially gaining insight into is the direct impact of various amounts of water, fertilizer, and electricity usage on the resulting yield as a function of basically the macro level view of our indoor farms, and also the product and the farm level view, which immediately gives us some really cool insights into what might be, if our goal is to reduce footprint, what might be the, the way we could best do that without overall impacting in a negative manner the yield that we're generating. So that's the application, and you see starting from nothing, uploading my data and visualizing the data. It's really that easy, and you can paste your CID here, regenerate the results, and it really shows you what's possible when we utilize blockchain technology for basically having an open standard for both data and the visualization of the indoor farm data that we have. So I've shown you what it looks like when we upload some data, but now suppose I'm a new farmer and I want to bring in my data into this procedure, bring in a new farm. So it's as simple as we take that data format that we described before, append to it, and upload our data. So let me give you a little example here. So in this form, what I'm going to do is I'm going to actually upload a appended data set, which includes a new farm. So I've appended my own data to the existing data. I get my new CID link. Let's go ahead and punch it in here, reanalyze that. You'll see after a small amount of processing, we get new results here, but let's go back to the tab we were just on. Look at electricity by farm, and you immediately see a new interplanetary farms has been added to the outputs, and you'll actually see that in all the by farm data. And it's that simple, basically just taking the existing structure, appending to it, appending my own data, and immediately the application is able to recognize that addition, reprocess the data, and reprocess the outputs that we visualize. Okay, so I'm going to hop back into the slides here. So our submission link is on this GitHub, and we wanted to cover basically the components of it. So basically, novelty and creativity. So we think the open data standard and the application itself is crucial, but really there does not exist a notion of that right now. And so we believe that's a novel application of using decentralized data storage to capture, track, visualize environmental impact data. Now, impact itself, because inputs to production information like this is not really tracked in an immutable, decentralized manner, and because this is already a multi-billion-dollar industry that's growing, really the efficiencies due to accountability could have substantial monetary and environmental impact that increases over time. This is a huge industry that's only growing ever larger, especially as the population of our world grows, and food scarcity is a real problem in regions. To be able to track this is something we believe could have an immeasurable impact on society as a whole. As far as technical accomplishment, we built a complete web application. It's non-subscription, it's open source. It's as simple as you saw, just pasting in your CID, uploading your data, and then visualizing the results. And you have QR codes to make this shareable, direct links so that you can access this information from any number of devices. And so we believe from a technical perspective, this is a pretty innovative way of visualizing and analyzing the data that indoor farms specifically would be producing. As far as Filecoin and IPFS, we use IPFS under the hood as you saw. So we connected to the IPFS daemon. You can also use a pinning service like Pinata as a public gateway for data upload and retrieval. And both of these IPFS node connection and Pinata public gateways, they're redundant ways so that users who want to interact with the app with minimal effort on the go can do so. And so there's a number of ways to connect to it. You saw how quick and easy it was, and we want to make sure it's simple and easy enough for everyone to interact with if they want to. And you saw the design. So the design, we tried to keep both a minimalistic but also like a appealing kind of design. We're targeting farmers and trying to make the UI UX as easy to use as possible. And so that's clean visualizations where you immediately can interpret the results, not too much visual clutter, something that is accessible to a wide variety of people, whether they have a technical background or not, because that's really the goal here. We want to encourage as much adoption of this standard as possible. It's really our hope that both the data standard and the application, it's going to kind of promote the tracking of energy consumption in vertical farms, because I think if the more people that get involved in doing that and kind of see the vision for what we're trying to do, that helps us all to be better stewards of our resources as we continue to grow as an industry. So ultimately, that's the fundamental conclusion here. Let's grow sustainably together. So we hope you enjoyed our presentation. We hope you enjoyed the application. And thank you for your time, and thank you for watching this video.